this video, we'll talk about how to factor the sum and difference of cubes. Let's get started. Before we get into factoring using the sum or difference of cubes, I want to verify with you that it works. Okay, so we'll multiply a plus b times a squared minus ab plus b squared. Okay, and I'll talk about kind of why that works and the pattern of it as well. Okay, I'm going to multiply a times a squared and get a cubed, a times negative ab and get negative a squared b, and a times b squared is plus ab squared. Okay, and then we'll multiply b times a squared, and I will get a plus a squared b, and a b times negative ab and get a minus a b squared, and then get plus b squared. Now, notice that because I have a plus in the left binomial and then a minus in the second term of the right trinomial, that those opposite signs work out just right so that these terms cancel out, and what I'm left with is a cubed plus b cubed. Okay, which means that this factors into this. Okay, I want to do the exact same thing with the difference of cubes as well. If I multiply together a minus b times a squared plus ab plus b squared, what do I get? Well, I'll multiply a times a squared and get a cubed. A times positive ab gets plus a squared b, and a times b squared is plus a b squared. All right, and then I multiply negative b times a squared, and I get minus b minus a squared b. And then negative b times ab, I get minus ab squared, and negative b times b squared is minus b squared. Again, those different signs between the left binomial and the second term of the right binomial, those opposite signs create the perfect case that we need so that these middle terms cancel out, and this time I have a cubed minus b cubed, which means this factors into this case. Okay, now there is a case for the sum of cubes and the difference of cubes. Here we go. You will always, always, always start with the GCF. You'll check that before you try any other factoring method. So you'll first factor out the GCF, if possible. Then, if the polynomial is a binomial, meaning two terms, with a cube as the first term, a cube as this last term, and has either plus or minus between the terms, then we'll use the sum or difference of cubes. Okay, now this is being written as two different patterns, but to me, they're really the same pattern. Okay, so I think about whatever sign is here, I use the exact same sign. Okay, and then whatever that sign was, I use the opposite sign here. And I'll talk that through as I do a couple of these together. Again, whatever this sign is, this first one's the exact same as that one, and then this one is the opposite one. The last thing is always plus. Okay, so I'll kind of talk that through, but that's the pattern that we're going for. So here's the first one. Example 1, we're asked to factor x cubed plus 125. Okay, now, is there a GCF, a number that divides evenly to x cubed and 125? And the answer is no, because the leading coefficient is 1. I have no variables in 125, so there's no GCF. Now, is x cubed something cubed? And the answer is, yeah, it's x cubed. Okay. Now for 125, you may or may not have your perfect cubes memorized. If you have a calculator, you can look at perfect cubes and look at cube roots of things. 125 actually is a perfect cubed. It's 5 cubed. So these are cubes, and this is the sum of cubes. Okay, so here's the pattern that I use. I ask myself, what cubed is x cubed? And the answer is x. Okay, same sign as before. Okay, and then what cubed is 125? And the answer is 5. Okay, and then I keep my eye on this as I move forward to do this other trinomial. Okay, so I do this thing squared, x squared. I do this times this, so x times 5, change the sign. Okay, so x minus 5 is 5x, but I change the sign and get a minus 5x. All right, the last thing I do, I take the last number, 5, and I square it, and I get plus 25. Okay, and this is what I get. I get x plus 5 times x squared minus 5x plus 25. Okay, now there's kind of a lot to that. We kind of just diagram this again. I guess it's up here. So I have this first, the cube root of this, same sign, the cube root of this, and then I square that. Okay, I do this times this, change the sign for this, and I have that last thing squared. Okay, there is kind of a lot going on there. Let's try one or two more. Okay, in example 2, we are factoring 1 minus m cubed. Okay, so is there a GCF, a number that divides evenly into 1 and m cubed? And the answer is no. Okay, there's no GCF. Okay, are they cubes? Is 1 something cubed? Well, yeah, it's 1 cubed is 1. Okay, and is m cubed something cubed? Yeah, it's m cubed. So they are cubes. Okay, and this is a difference. Okay, now the pattern to me is the exact same. Okay, what cubed is 1? And the answer is 1. Same sign. Okay, what cubed is m cubed? And the answer is m. Okay, and now I keep an eye on this as I move forward. Okay, the first thing, 1 squared is 1. Okay, and then I do the first thing times the last thing, but change the sign. So what is 1 times m, 1 times negative m, and then change the sign, you get plus m. Okay, and then you square this thing, negative m times negative m is plus m squared. So this factored is 1 minus m times 1 plus m squared. Let's try one more. In example 3, we're going to factor 112x to the 4th plus 14x. Now, is there a GCF? We always start with the GCF. Okay, and it looks like we have some common multiples in the two terms. Okay, and 14 does divide both 112 and 14. Okay, and there's at least an x in both of them. So the first thing I'll do is I'll factor out that GCF of 14x. So I'll write 14x, and then 14x times what is 112x to the 4th, and the answer is 8x cubed. Okay, and then 14x times what is 14x, and the answer is plus 1. Okay, so now I'm looking at 8x cubed plus 1, and that is things cubed. So 8 is 2 cubed, and x cubed, x is x cubed, and 1 is 1 cubed. So these are now cubes. It's the sum of cubes. Okay, I will keep my 14x, my GCF. I don't want to lose that. That would be bad if I lost that. Okay, and then this pattern. What cubed is 8x cubed? And the answer is 2x. Keep the same sign. What cubed is 1? And it's 1. Okay, and then I keep an eye on this as I move forward. 2x squared, be very careful with this because it's 2 and the x. 2x squared is 4x squared. I then multiply this times this and change the sign. So 2x times 1 is 2x, but I change the sign to get minus 2x. And then I square the last thing. 1 squared is 1, so plus 1. And this is what I get. I get 14x times 2x plus 1 times 4x squared minus 2x plus 1. All right, in this video we talked about how to factor the sum or difference of cubes. Thank you for watching.